In this video, we'll learn about car paint shader in Arnold for Cinema 4D, which can be used to create realistic car paint shaders. Let's jump right in and create a new Arnold car paint shader. Assign it to the shader ball and middle click on it to open up its network editor. And let's run the IPR. Car paint, like a standard surface shader, has a base, a specular, and a coat layer with some additional parameters and a flakes layer. I don't intend to explain every single parameter in the car paint shader, as most of them are the same as in a simple standard surface shader. In the car paint shader, under this presets tab, you notice if you click on this load preset button, there are a few car paint presets like black, metallic blue with flakes, metallic red, and so on. For now, let's use this metallic blue with flakes preset. Car paint shader has 4 layers: base, specular, flakes, and coat. Combining these 4 layers, we can produce all sorts of car paint shaders. First, let's zero out the specular weight, the flakes density, and the clear coat weight. First, we have the base layer. Then we add the rough specular reflections using the specular layer. And you notice the IOR for this layer is set to 6. That's why we get this metallic look. Then we add the flakes if necessary. And finally the clear coat layer, which adds a sharp reflection on top of everything. Let's zero out the specular weight, the flakes density, and the clear coat weight again. The base layer controls the base or diffuse color, weight, and roughness of the shader. For a metallic car paint, you normally have a much darker shade of your defined specular color as your base color. Then on top of your base layer, you add your rough specular layer. So set the specular weight back to 1. To get that metallic car paint look, you notice the specular color is brighter, more saturated version of the base color. If we were aiming for a normal paint, the specular color would have been a simple white. You notice here the roughness is set to 0.5. That's why we get these broad specular reflections, and the IR is set to 6, which helps us to get closer to a metallic car paint. If I lower it to a normal value like 1.5, we immediately lose that metallic look. So let's set it back to around 6. To achieve that car paint look, we do need a clear coat layer. So go to the coat section and increase the weight to 1. And this gives us that sharp specular reflection layer on top of everything. You realize this is a simple, sharp reflective layer with roughness set to 0.01 and IR to 1.5. And finally, we can start adding flakes using the flakes section by increasing the density to something more than 0. In this case, let's try 0.4. The clear coat layer will sit on top of all the other layers, including base, specular, and the flakes. Now, we can control how these flakes look using this set of parameters. For now, let's turn off the flakes again and get back to the specular section to talk about a few parameters that you might not be quite familiar with. And by that, I mean flip-flop and light-facing colors. Flip-flop allows you to control the specular color based on the viewing angle. So if you want, you can have different specular colors on the parallel and perpendicular faces to your viewing direction, and this can be used to mimic a pearlescent effect. To do that, let's add a ramp RGB node and connect it to the flip-flop color. In the ramp RGB node, change the type to U. Let's change the black color to red and the white color to yellow. So now the parallel faces are having this red specular color and the perpendicular faces having a yellowish specular reflections. And you can control the exact way these colors appear, the exact angle, the transition between the two, or even add more colors. Obviously, you would want to use more subtle transition and colors. Let's change the red color to the original cyan color and the yellow color to this bright pink. Then we have this light facing color, which modulates the specular reflection color based upon light sources. So if a section of the geometry is facing a light source, it would get the color that you define in the light facing color as its specular color. Let's see how that works. I'm going to change the light facing color to this bright green. Right now, because the fall-off parameter is set to 1, we don't see any contribution from the light facing color. So let's set the fall-off to 0.3 for now. Now immediately this green reflection comes to play. Now let's temporarily turn off the Arnold sky and add a new Arnold point light and position it in the scene. I'm gonna set the radius to 0.05 or something like that. And in the IPR, make sure the render camera is camera 01. Now, if you run the IPR and move the light around, you notice how this green color appears only where the geometry faces the light source. For now, let's turn off this light and turn on the Arnold sky back again. This fall-off parameter here controls the fall-off rate of the light facing color of the specular reflection. The higher the value, the narrower the region. So at 1, you only get the flip-flop color as the color of the specular reflection. And as you decrease it towards 0, you start to blend in the light facing color as well. Now at this point, let's add some flakes. I'm going to increase the flakes density to around 0.4. You notice you normally use the same color of the specular layer for the color of the flakes as well, but because the IR value is higher, around 100, you can see the flakes independently from the specular layer. In the flakes section, you notice we have the flip-flop, light facing color, and fall-off, which are operating exactly like the same set of parameters in the specular section. To see how they work, let's set the flakes color to white and connect the same ramp RGB node to the flakes flip-flop. And use the same green color as the light facing color for the flakes and decrease the fall-off to around 0.3. Now we have modulated the flakes color using flip-flop and light facing parameters. So the flakes that are oriented towards a light source become green, the flakes at the glancing angles are pink, and the parallel flakes, the viewing direction, are blue. For now, let's set the flakes color to red so we can take a look at the parameters available in the flakes section as well. I'm going to disconnect the ramp RGB from the flakes flip-flop and make sure light facing color and flip-flop colors are set to white as well. And set the fall-off back to the default of 1. We can set the flakes color to red so we can take a look at the parameters available in the flakes section. This scale value scales the flake structure up or down. Smaller values zoom out of the map, giving a larger number of flakes. Right now the scale is set to 0.001 and we can actually see the individual flakes. If increased to something like 0.005, now we get even bigger flakes. We can set the scale to, let's say, 0.0001 for this scene to get small flakes. And so depending on your scene and how big or small you want the flakes to be, you can actually adjust the scale value here. For now, let's set it to 0.005. Density controls the density of the flakes. There will be no flakes if it is 0. As we increase the value towards 1, we get more and more flakes, and the surface is fully covered with flakes at 1. Let's use 0.4 for now. Layer specifies the number of flake layers. The flakes at a deep layer are covered by the ones closest to the surface. When set to 1, we only get 1 layer of flakes. At 2, we have 2 layers, and at 3, 3 layers, one on top of another. Let's set it back to 1 for now. Normal randomizes the orientation of the flakes. At lower values like 0.3, the flakes have roughly the same orientation, and at values closer to 1, the flakes will be oriented more randomly. For now, set the randomize parameter to 0.3 and set the scale to something like 0.0001. and set the flakes color to the same sign color as the specular color. Let's add a new car paint shader and connect it to the beauty port. You can load different presets and see how they use the parameters available in the car paint shader to achieve them. For example, let's load this metallic red preset. You notice it doesn't have flakes. We can simply increase the flakes density to something like 0.5 and use our bright red specular color as the flakes color as well, and set the scale to 0.00001. So we get much smaller flakes. And here is our metallic red car paint with flakes. To achieve other car paint colors, you can simply change the base color, the specular color, and the flakes color. I'll be creating a few car paint materials and shaders and saving them in the finished version of the scene. You can check that out. So that's about car paint shader in Arnold for Cinema 4D.